Hi everyone, this is a video that I'm recording for my GCSE Electronics students, and hopefully you will be able to follow the instructions I'm going to give you in this video, and you can at least make a bit of a start on some work in the week following the Easter break. So what I'm going to show you is going to be based on some of the EDUCAS worksheets, but the EDUCAS worksheets are much better explained so you can actually see stuff happening, and particularly the stuff in Circuit Wizard. So that's why I've split my screen like this. And if you want to find the worksheet, I've placed the worksheet or links to the worksheet from my website, pitsytechnology.com. Now, just before we do that, let me just quickly show you the current structure of the website. It's likely to change, it's constantly evolving. And so if you click this, in fact, if I just maximize the website, you'll notice that navigation bar or panel stays there all the time. But GCSE Electronics is split into three major components. And although it's not a component, Genie Microcontrollers are such an important part of the GCSE Electronics, I've actually split that up into like another section there. Now, component one, we've done most of component one already this year in year 10. Component two, remaining, you've got to learn about control circuits and operational amplifiers. Well, control circuits is going to be the topic in this video that I'm going to get you started with. And component 3 is the coursework. Now, I do recommend you having a look through the component 3 stuff at some stage, but we're not going to look at it in any detail in this video. But what I would stress is that chapter 4, which is all about using microcontrollers, is something that's highly likely you're going to be interested in doing, because you can make yourself a nice, interesting, programmable project that, although the circuit, the actual wiring of the circuit is quite simple, you can actually have quite an interesting, fun, entertaining type project, maybe like an electronic game or something like that. And it makes it so much easier for you to be able to achieve all the targets of the mark scheme to get a really good grade, plus enjoy yourselves. I really do recommend you at least consider using an integrated circuit, a programmable integrated circuit known as a microcontroller. Anyway, so let's just have a quick look at chapter 4. So this is component 2, chapter 4, so you should be able to navigate your way to that. And you'll see that at the top there's a couple of links about stuff with microcontrollers, and component 3, the coursework, would be worthwhile you having a look at that. And there's also a little embedded presentation here. You can just click these things and then they open up full screen if that's what you want to do, or you can play them like this. Okay. The link to the EDUCAS book, this is the, well, let's just click out. You'll hopefully be familiar with these because I print these off for you in the classroom, but here you've got an electronic copy. Now, I did originally have it embedded in the page, so you didn't actually have to like open up another tab. But I did check with EDUCAS, and they weren't so keen on the idea. They wanted links, which fair enough. So I changed it to a direct link. Now, so we're going to have a look at that in just a moment. But just before we do that, let's just have a quick look at this thing called Genie Microcontrollers. Now, there's a bit of information here about what a Genie Microcontroller is. There's a video that you might be interested in having a look at. And there's a data sheet for a Genie 08 microcontroller. Now, the Genie 08 microcontroller has 8 pins. Let's just maximize this. Genie Microcontroller has 8 pins. That's why it's an 08 microcontroller. And it can do loads of stuff that you would find very difficult to do using any of the electronics knowledge that you have thus far. So you can do digital input and output. You can also have analog input. You can make timers. You could even make a simple game. You could play music. You could do all manner of stuff. Now, some of those features, or all of the features, are actually listed there on the left. And you can do all that using a very, very simple circuit. In other words, what I mean is, very limited wiring of the circuit. And yeah, so you're going to find that quite fun. So it really is worthwhile doing. We're not limited just to a Genie 08. There's Genie 14. Genie 14 has 14 pins, has more inputs and outputs, and also has some other more advanced features. And there are other Genie microcontrollers as well. To program the microcontroller, you need to use Circuit Wizard or the Genie programming editor. You can download that for free in an email which I'm going to send to you. You can also download a student copy of Circuit Wizard too. Let's just go back to component 2, control circuits. And so just whizzing through some of the objectives that hopefully things that you will achieve by going through this particular chapter. You're going to learn about how a microcontroller is something that you can program. You'll understand that you can have various sensing circuits and outputs driven by the microcontroller. You can program using a flowchart type language, and you'll start to understand and appreciate that microcontrollers are very widely used because they can be programmed in many different ways. They can solve many different tasks, and then we're going to learn a little bit more about flowcharts and ultimately learn something about servo motors as well. Do read through this stuff. You're at home, I'm aware of that. There's nothing I can do to force you to read this text, but it is actually useful, so I'm not going to read it to you now. It just makes the video unnecessarily long. There's some advantages and disadvantages of microcontrollers here. Now, the obvious advantage is that you can just program it to do multiple different tasks. You reprogram it to change the task. And one of the disadvantages that they note here, they say that it's more expensive than other ICs, integrated circuits. Now, be aware that let's have a look at Genie Microcontrollers here. And yeah, more expensive. Well, I've pasted a link into a video, or embedded the video here from a guy who reviews a microcontroller that only costs 3 American cents when it's bought in bulk. So just be aware that although microcontrollers traditionally have been quite expensive, they are much cheaper now than they ever have been, and yeah, so you can get really cheap ones, especially no-name brand type ones. Yeah, if it comes to the exam, you're asked for a disadvantage, you could say they're more expensive, but just bear in mind that that's not always strictly true nowadays. Yeah, you will need a computer and programming software and download cables and programming board to be able to program the microcontroller. There's a little bit of stuff that you should read through there, and there's stuff about, well, flowcharts and things. Hopefully you're familiar. No, you should be reading this yourself. Hopefully you're familiar with some of these types of symbols. You've probably seen them, whether it's in geography or something, or maths, that hopefully you're familiar with seeing at least some of these flowchart symbols. This is a terminator. So, start and stops terminator. That's a process, whatever it happens to be, the process, like, setting a variable. A variable is just an identifier, which you can then have a value. That's a decision box. Or a selection box, and based on the statement, whether it evaluates to true or false or yes or no, then it can conditionally branch, and that's an input or output box. Now, the EDUCAS worksheet that we're looking at the moment is generic in that it's not made just for Genie and Circuit Wizard. So yeah, so there are other programming environments. They've listed several off there, but we only use this one. So when we have a look at the flowchart they're going to present here, this is a bit of a generic one, so it's not specifically for Circuit Wizard. So we'll interpret this for Circuit Wizard. Okay, so looking at the first example, and they say that you're going to make a control program for a child's toy. The switches a red LED on for 5 seconds, then turns a red LED off for 2 seconds, turns a red LED and a blue LED on for 3 seconds. Now, bearing in mind, if you could do this with timers and some system of logic gates, and you'd probably find that quite difficult, wouldn't you? But with a microcontroller, it's really quite straightforward. Now, because we've got a red and a blue LED, each one of those is going to need to be on a different output. And so they've named these outputs B0 and B1, presumably binary 0 and binary 1 or something like that. Okay, but when we use our Genie microcontroller, it's going to be called G0 and G1. Just warning you about that now. And so there's the flowchart. Turn one of the outputs on, then wait for 5 seconds, turn that output off, wait for another 2 seconds, turn that output back on again, then turn the other output on, then wait for 3 seconds, then turn the first output off, and then turn the second output off, and then stop. Okay, so yeah, we can do that. Now, later on, when you go through this, you'll actually see that they've got this investigation where you're actually supposed to be constructing these using your flowchart program, using Circuit Wizard. Okay, so that's what we're actually going to do. So I'll show you how you can get started in doing this one, and I'll do that in Circuit Wizard then over to you to try solution 2. Circuit, this first one actually is not a great solution. There's problems with it, and yeah, you'll understand what problems are as you develop it. So let's just whiz over there, and let's get Circuit Wizard. Now, hopefully you've downloaded it. Let me remind you that I'm emailing you a link with so you can download Circuit Wizard from the school. And so what we're going to do is create a new file. And we need to make an electronic circuit, and it must, in this particular instance, I've always told you this, choose the one which says with Genie Flowchart. Well, this time it's absolutely imperative because we are going to use a Genie Flowchart. So click on OK. And then so the first thing, I'm going to add a power supply. Now, let's just have a battery in here. Now, if I have a look at the datasheet for the Genie Microcontroller, you'll see that the power supply must be in the range of 1.8 to 5.5 volts. Well, 5 volts is in that range. However, probably more likely you're going to use 3 1.5 volt batteries if you make this. So I'll just change that to 4.5 volts because 3 times 1.5 is 4.5. Just zoom in a little bit here. And so then we're going to need the microcontroller. So that's an integrated circuit, and we go to microcontrollers. And although we're going to use the Genie 08, and the first one you see here is the Genie 08, note this is the elementary view. Do not use this one, okay? Don't want to explain why. I can maybe tell you in the class another time. Use this one, the dual inline package, the one that looks like the actual thing. And let's just connect the power up. That's V+. V0, or 0 volts rather. You could connect it around like that if you want. That's absolutely fine. You could also, if you wanted to, you could go to power supplies like so, and then you could get a ground. And I'll control drag this. So if you want, you can do it like that. Can I just remind you though, if you do use a ground symbol, the ground symbol should always be pointing downwards by convention, although that actually performs the same function. That's considered rather unusual and non-standard. So don't do that. Make sure that whenever you use a ground symbol, a ground sign, it's like down like so. Okay. So it doesn't actually change function. It's just like by convention. You can move these things around to wherever you like. Now, if you're using the Genie 08 microcontroller for real, not just in the simulation, but for real, let me just warn you that if you don't have the programming socket, the download socket, and these couple of resistors in, sometimes the microcontroller can be a bit slow to start up. And there's an easy fix for that. So if you're not, they say this is a minimum circuit, but that's not the minimum circuit. This is the minimum circuit. But if you want it to work reliably, you just need one additional resistor. And I've made a video about this quite a long while ago, I think. But connect the resistor to the programming pin. Let's make it a 10K resistor. 1K would actually work, but 10K is probably better. And let's just pull that down to ground. So you'll see, hopefully you'll see the programming pin is pulled down to ground via a 10K resistor. That will mean then that when we run this for real, if you actually build this circuit, you won't have any problems with the microcontroller starting up. You wouldn't have any problems if you use this circuit either, but if you just leave the programming pin floating, not connected to anything, then there can be problems. Okay, so let's just go back to the flowchart, and if you remember, there were two outputs, B0 and B1. Well, I don't have Bs, but I've got Gs, so I'm going to use G0 and G1. We need to check that these are configured as outputs, because remember, the LEDs are connected to outputs. And to do that, I need to click this thing and go on to Program Settings. And you'll see that it's already selected Genie 08, V2, Genie 08. Okay, it's this one. There's different versions of it, but we'll use the Genie 08 V2 for the moment. And hopefully you'll see that all the pins are arranged as either inputs or outputs. And G1 is currently in the input column. You can just swap them over like that. Okay. But we do want it to be an output. Now, if you left it as an input, let's just click on the device view. you'll see that G0 is an output, the arrow comes out, but G1, the arrow goes in, so that's an input. Okay, we don't want it to be an input because we want it to be an output, so I just click it like that. Okay, so, and it doesn't change this view at all. It's really important that you do remember to do that. So always go there, go to program settings and make sure that your outputs are actually configured as that, or the pins are actually configured as outputs if that's what you want to do. Otherwise, when you do the flow charting, you'll find you'll have problems. Okay, so the next thing we need to connect up the LEDs. Well, we need current limiting resistors, so let's just get a couple of current limiting resistors. Now, they're a red LED and a blue LED. Now, you probably remember that the red and blue LEDs have different forward voltage drops. So strictly speaking, we would need to know the forward voltage drop. So if it's a red LED, it's going to be about 2 volts drop and 4.5 volt supplies. That means we've got about 2.5 volts dropped across the resistor. At 10 milliamps, that's going to be a 250 ohm resistor, but you know, we don't really need to worry about that too much in that level of detail. So I'm just going to go for an approximation of 220 ohms. The blue LED will have a larger forward voltage drop across the LED, which would mean there will be less volts drop across the resistor, but I'm not worried about that at the moment. Okay. And nor should you be particularly bothered about that either, unless unless you actually look at the data sheet for the LED, you're not going to know the precise forward voltage drops anyway. So we got those 2 resistors. I just control dragged if you didn't realise that, and go down to LEDs. Let's drag an LED in. Let's control drag there. Connect them up, and let's have a ground. Let's just comment it there. And so G0, B0 was red, so that's going to be fine. By default, that's going to be red. Let's just check. Yep, that's red. The other one's blue, of course, so let's just change that to blue. And if you were try to run this now, what you'll find is that it's not going to work. Now, look down here at the bottom. You'll see circuit diagram, PCB layout, flowchart. Flowchart is like it's got start and then nothing else. Okay. Now, if you try to run, you'll see we're taken to that flowchart page, and it says incorrect flowchart, bad path, because it doesn't know what to do. You know, what start and then do what. You know, where's the path going leading on next? Okay, that's what it's talking about, and that's why it's complaining about this. So it tells us you should add an output path from this command to a stop command, blah blah blah. Okay, so we need to do something. I mean, at its very simplest, you could do that, but that's not actually going to do anything useful at all, is it? Of course, you know, it's running it, but what's running? It's doing nothing. Okay, nothing useful anyway. So let's just get rid of that. Just click on it and delete. And so now we can start building the flowchart. So we want to turn output B0 on, and that, as I say, is G0. So we go high. So high, what goes high? Well, G0. And then we want to delay for 5 seconds. There's no delay in circles, there's wait. So let's just drag that in. So wait for 5. You can just type 5 if you want, or you can scroll on down. Makes no difference. Wait 5 seconds and then turn output B0 off, G0 in our case. So it's just, when it says off, it just means low. So that was G0. And then wait for another 2 seconds. I'm going to control drag, it's just quicker. Change that to 2, so that's now 2 seconds. And then turn output B0 on, that's G0 on, of course, I'll just control drag that. And then turn output B1 on, so I'm going to, that's going to be high, let's change that to G1. So now we've got G0 on, or high, G1 on or high, so turn that one on, turn that one on, and then wait for 3 seconds. Oh, sorry. That's 2 seconds at the moment, so let's just change that to 3. And then turn G0 off and turn G1 off. So that's G0 off and then G1 off. Now, You may have thought, isn't there a better way that I can turn the two outputs off simultaneously? Yes, there is, but this is solution one. And if you read through the next solution, you'll see that that's one of the problems with this. You've got to have a stop, otherwise the path isn't correct. It just goes to wherever. It doesn't know where to go next. And you could run the simulation here. And of course, you can't see any LEDs going on and off. If you want, you can view the digital inputs and outputs like here, and it will then show you those inputs and outputs. Of course, we're not doing anything with the inputs in this flowchart, but we will be in later ones. It's got to the stop, so it's stopped there. But you don't see your LED, so you can go back to your circuit diagram, and then you can run it here, and you'll actually see these LEDs going on and off as we've programmed them. So I think the next one was both of them on. Yeah, that's right. So they're both on, and then they both get turned off and the program stops. If you want, when you run this, you can also see the flow charts running at the same time. By the way, when you're running this view, when you've got the flow chart and the circuit simulated at the same time, invariably runs a bit slowly. Okay, so just be warned about that. But hopefully you can see that, and you can zoom in and out as well, of course. Okay. Right. So what am I expecting you to do? Well, get Circuit Wizard installed if you haven't done so already. Read through, have a look at some of this stuff which I've shown you in the video today, and play the video again, and then just pause it and then have a look at some of this stuff. That would be really useful to you. Then have a read through to page, whatever it is, page 5, 6, and then have a go at solution 2 as a modifier. So we've done solution 1, or you hopefully will have done solution 1. There's a couple of problems here, so read through that, check that you understand it, and then have a go at solution 2. And then once you've done that, then have a go at seeing if you can answer these questions, and then do this traffic light sequence, which really isn't too difficult. Now let me just have a quick look here. Yeah, you can. It's going to mention that some flowchart programs allow you to turn multiple outputs on or off, and if you want to do that, in fact you should do that at some point. Let me just quickly show you that you can use outputs. So you drag that one in, and then if you double click that, then say you can turn on multiple outputs, or turn them on or off, or whatever combination you want simultaneously in one thing. Okay, so that would turn G0 and G1 on high simultaneously. Okay, so do use that at some point. The first solution doesn't use it. I'm not sure if the second solution, yeah, the second solution does use it by the look of it. So give that a go. Later on in the week, I'm going to post some more videos as well. And a lot of this stuff, as soon as you've got to grips with just dragging these flowchart symbols in, it's quite easy to use. Now, I've had students, I alluded to at the start, I think I did in this video, about you could use a microcontroller to make a game. A lot of my students in the past have made really successful games, played music and stuff, and it's not doesn't require a very complicated circuit either. So I think that once you get into this, you're going to really enjoy it and see that you can make yourself a nice component-free project using a microcontroller. So do give it a go. If you've got any questions, if you're one of my students, just send me an email to my school email address, and I'll try and get back to you. Do give it a go. Please give the video a thumbs up, just so I know that you're watching it. You can, of course, always add a comment, but probably just as good to send me an email as well. Okay, that's it for now then. Thank you.